or negative 3. I know that this is positive 3, but an r value of 5 and a y value of 4, positive 4, couldn't that also be somewhere over here? Couldn't theta also fall over here? That has a y value of 4, positive 4, it's still theta, except, and its r is 5, but look at its x value. Its x value is going to be here, negative 3. Same distance there and there, except now it's negative. So to sketch this angle, sine theta is equal to 4 over 5, it could be either that angle or that angle over there. The next one I gave you to do said that cos of theta is equal to negative 3 over 6. Now remember, cos is the function x over r. So we are looking for the x coordinate negative 3, which is over here, negative 3, and the r value of 6. Now at negative 3, that's that line over there, x is equal to negative 3, our r value is equal to 6. So that means that we are either working with that angle over there, which is a theta of x value negative 3, so that's negative 3, and an r value of positive 6. Remember, r is always positive. To get the distance here of y, if we need to, we're going to say y is equal to square root of 6 squared minus minus 3 squared, which is equal to 6 squared, which is 36, minus 9 in the square root, which is equal to square root of 27. That means that y is equal to root 27, but because it's a square root, it can be positive or negative. Is that true? Yes, it is, because this line, this here, could also be negative root 27, which means that theta could also be over here, again with an r value of 6, but theta is over there. Both of them have an x value of negative 3. So theta could be either that one over there or that one over there. The next one I gave you to do read tan of alpha is equal to positive 3 over 5. Sorry, positive 5 over 3. Now remember, tan is the function y over x. That means our y value is 5 and our x value is 3. Y value of 5, x value of 3 means that our angle falls somewhere over here, and that is angle alpha. It has an x value of 3 and a y value of 5. If I wanted to calculate my radius, again, right angle triangle, all I'll do is I'll say r squared, in fact r is equal to square root of 5 squared plus 3 squared, which is equal to square root of 25 plus 9, which is equal to square root of 34, and r is always positive. But is this the only angle that adheres to that? No, it is not. The other possible angle that could adhere to that is negative 5 over negative 3, wouldn't negative 5 over negative 3 also give us positive? Negative divided by negative is positive, right? So alpha could also come where x is equal to negative 3 and y is equal to negative 5, which means that alpha could also be somewhere over here. That's alpha. That is equal to negative 5 and that is equal to negative 3. R again will equal root 34. So there's two possible alphas. Notice the pattern with every single angle. Because I didn't give you restrictions and tell you in which quadrant to sketch it, there's always two angles. Either it's positive or negative. Keep that in mind. The next one I gave you to do read sine beta is equal to negative 1 over 3. Now remember, sine is the function y over r. That means that our y value is equal to negative 1. Our r value is equal to 3. That means that beta could either come over here with an r value of 3 and a y value of negative 1, and that would give us beta. Now, to get our x value, again, if we needed to, this is a right angle triangle, right? So x squared would equal r squared minus y squared. That means that x is equal to r squared minus y squared, which is equal to square root of 3 squared, which is 9, minus 1 squared is 1. 9 minus 1 is equal to root 8. That means that the x value, now it could be positive or negative. If it's negative root 8, that means that that x value is equal to negative. Root 8 is the same as 2 root 2, by the way. But x could also be positive. That means that it could also fit over here with an x is equal to positive 2 root 2, which means that beta could be over here as well. Again, two angles could be formed because I didn't give restrictions. Both of them have an r value of 3 and both of them have a y value of negative 1. The last one I gave you to do said tan of A is equal to negative 8 over 5. Now remember that tan is the function y over x. We are looking for y being equal to negative 8. That's over there. Y is equal to negative 8 and x is equal to positive 5. So that would be somewhere over there. That means that A would be this angle over here. That would be angle A, where x is equal to 5 and y is equal to negative 8. That means that r would equal negative 8 squared is 64 plus 5 squared is 25. 64 plus 25 is equal to 89 in the square root. That means that r is equal to square root of 89, and by the way, it's always positive. Is that the only solution? No, because what happens if x were equal to negative 5 and y were positive 8? Wouldn't that still be negative 8 over 5? So it could be y is equal to positive 8 and x is equal to negative 5, which would go somewhere over there, which means that my angle, well, actually it would go somewhere over there, which means that my angle A would be over there with an x value of -5 and a y value of +8. Again, r would still equal √89. And that brings us to the end of the first trigonometric tutorial. I hope you had fun. The next tutorial is titled Reduction Formula. Go through the exercise that I left for you in the workbook before moving on with the next tutorial.